moves around and over the Great Lakes region in an intricate network of pipelines, trucks, railroads, and cars. Ships, like those in the Great Lakes, are powered by bunker crude, although some of the more modern models use diesel, electric, or natural gas. But what would happen if oil was spilled in the Great Lakes? Oil and water do not mix, as catastrophes like Deepwater Horizon in the Gulf of Mexico have made clear. The National Oceanic and Atmospheric Administration and its seagrant program know we could be better prepared for oil spills, which has led to research about how oil moves in water. Minnesota Sea Grant funded a project that is modeling how oil is predicted to move if spilled in the lakes such as Lake Superior. Understanding currents, winds, waves, and the interactions among these elements is vital to solving this puzzle. So is the University of Minnesota's supercomputer and Dr. Lian Shen.
It's about using computer simulations to study the transport of spilled oils at the lake surface. And what is unique about our work is we study the effect of wind, the effect of water waves, and the effect of currents and the interaction among those different processes. So this is an extremely difficult problem, and then what we use is we use computers to simulate the process, and actually we are using big computers, supercomputers, to deal with this. This problem, it is so complicated because, as we know, when such things happens in nature, then we have current, we have water waves, we have winds, and they can all have different kinds of combinations. And now you have spilled oils at this water surface, and they might sink, they might stay at the surface, depending on different conditions. So this study actually involves quite some other disciplines, like in biology, like in ecosystem. And we focus more on the physical side about the fluid flows. But the fluid flows with oils, they have consequences on many other things.
Shen says that although small-scale oil spills in freshwater environments may not get as much media attention as large-scale oil spills in oceans, they can still cause a lot of damage.
That is something unique about the lake environment, different from open oceans. Open oceans, it is open, and spilled oils can go elsewhere, But in lake environment, this ecosystem is confined in this fixed regime, right? So therefore, if something bad happens, really the damage can be serious. Keep in mind, when oil spill happens, it does not care what kind of weather it is. It might be on the very severe weather, for example, on a certain kind of high winds, hurricanes, storms. And if that happens, that can increase this damaging significantly, because the spilled oils with that kind of condition, it might be transported a lot further away, to affect a lot more. So therefore, under these kind of severe conditions, then that can be a lot more worse. But research-wise, then it poses even greater challenges. And besides the fundamental understanding of the flow physics, then also we wanted to be able to develop useful tools for people to use to deal with this once that kind of thing happened. And that is, we do computer simulations. So therefore, the long-term goal for our research is we hope to build a new generation of prediction tools, so that people can use that to say, oh, there's something happening, then can you tell me, where will those spilled oil go, 1 day later or something? That will help people coping it,
The results of this study could be useful in risk analyses and could help predict the trajectory if there were ever a spill in the Great Lakes. Computer simulations and research like Dr. Shen's are improving the accuracy of existing predictions by incorporating wind, waves, currents, and the properties of oil. The National Oceanic and Atmospheric Administration and other state, local, and federal agencies are working to prevent oil spills. However, they are also prepared to respond quickly and thoughtfully should there be one. The University of Minnesota Sea Grant program is committed to research like Shen's that seeks to help coastal communities prepare for hazards such as an oil spill.